In this video we will find the derivative of e raised to x using the definition of the derivative which we have written right here. First, let's define e raised to x as the following power series. Now from the definition we have the limit as h approaches 0 of e raised to x plus h minus e raised to x divided by h. Now we can factor in e raised to x out of this and then out of the limit. So we're going to have e raised to x multiplied by the limit as h approaches 0 of e raised to h minus 1 divided by h. Now we can factor this e raised to x out of this limit because we're only interested in what happens to h as it tends to 0. We're not really concerned about what happens to x. Now from our definition above, we know that e raised to h minus 1 is equal to the sum from n is equal to 0 to infinity of h raised to n divided by n factorial minus 1. This is equal to h raised to 0 divided by 0 factorial plus h raised to the first power divided by 1 factorial plus h squared divided by 2 factorial, and so on and so forth, minus 1. This simplifies to 1 plus h squared over 2 factorial minus 1. Now we have a 1 here, these two cancel, so we're just left with h plus h squared divided by 2 factorial, and so on and so forth. So let's go ahead and substitute this into the limit here for e raised to h minus 1. This gives us the limit as h approaches 0 of h plus h squared over 2 factorial, so on and so forth, all divided by h, multiplied by e raised to x. Now what we can go ahead and do is factor a h out of the numerator. Now these two cancel with each other and we can just plug in h is equal to 0. So this is 0 and everything else is 0. So we have e raised to x multiplied by 1, which is just equal to e raised to x. And that's the final answer to this problem. I hope you have a good day. Thank you very much for watching.